Hello grade 10s, we're getting into our last section, which is section 4.6, applying the exponent laws. So I'd like you to remember the exponent laws from Math 9. We've already discussed these, but it's the idea that if you are multiplying, then you add the exponents. If you're dividing, you subtract the exponents. If you have a power to a power, then you multiply the exponents. If you have two things in the bracket, then the exponent goes to both of them. And same thing if you're dividing, the exponent goes to both of them. I provided a little better table of this in the PDF handout in the Google Classroom. Let's get going and try some examples. Example 1, we're going to simplify by writing as a single power. So I want my answer to only have one power in the end, and the power should never be negative. So let's try the first one. Here we have the same base, so that means I can use my exponent laws. I'm multiplying these together, so when I multiply, I have to add the exponents. So that means we have 0.3, and the exponents are negative 3 plus 5. Again, I have to add them together. So that really gives us 0.3 to the power of 2. Now I can leave my answer like that because it doesn't say evaluate, it says simplify. Let's try the next one. The next one here, I see first of all that my bases are the same, so that's good. I can use exponent laws. Then I see here that I have a power to a power. So that means I have negative 3 over 2, and then a power to a power you multiply. So minus 4 times 2 is minus 8. Same thing with the next group. We have a power to a power, so 2 times 3 is 6. Now I'm multiplying these two things together, so when you multiply, you need to add the exponents. So we're going to go the minus 8 plus the 6, which means we have negative 2 as our exponent when we add them together. However, you can never leave a negative as your exponent, so we have to deal with that negative. Remember that the negative flips the fraction. So it's going to change it into a 2 over 3, and now the 2 is positive. So that will be our final answer. Again, you can never leave a negative exponent in an answer. Let's look at the next one then. Let's look at C. Here we are starting on the top. We have two things, we're multiplying them together, which means we're going to add the exponents. So the 3 and the 4 gives me a power of 7. That's divided by a power of negative 2. Now we're going to take these, and when you're dividing, you need to subtract the exponents. So we're going to go 7, subtract a negative 2, but be careful. The double negative there means add. So 7 plus 2 is actually 9. So this one's going to be 1.4 to the power of 9 as your answer. Now let's look at D. It's getting a little bit more complicated. When we're looking at D, I'm going to start by dealing with this outside exponent. So what I have to do is apply this outside of exponent to each of the inside exponents by multiplying, because it's a power to a power. So on the top, we're going to have 7 to the power of 2/3 times 6 over 1, or times 6. On the bottom, we'll have 7 to the power of 1/3 times 6, and 7 to the power of 5/3 times 6. Now you guys should notice that when you're multiplying something that's 1/3, and you're multiplying it by 6 over 1, that's really 6 over 3 or 2. So multiplying something with a denominator of 3 by a numerator of 6 is going to just give it 2 times bigger than the original numerator. So what I'm saying there is if I multiply these together, 2 times 6 is 12 over 3, which is 4. So really I'm going to have 7 to the power of 4 on the top. Here, 1/3 times 6 is 2. Here, 5/3 times 6 is 5 times 6 is 30 over 3, so we get 10. So 7 to the power of 10. So now that we've done that, now we can start using other exponent laws to keep combining. So on the bottom, the 7 squared and the 7 to the power of 10, these need to be added together because right now they're multiplying. So we get 7 to the power of 12. Now we're dividing. So when you divide exponents, you have to subtract them. So we're going to go 4 subtract 12. So 7 to the power of 4 subtract 12 is going to give us 7 to the power of negative 8. Now it's not allowed to leave that exponent as a negative, so I have to flip the 7 into a 1/7, and then I can have my power as an 8. So that's going to be our final answer here. 1/7 to the power of 8. Remember to pause the video at any time if you're getting a little bit behind at your copying, or feel free to re-watch it if it went a little too fast. Let's try example 2 then. Here we're going to simplify again. So again, just simplifying. Notice here there's different variables though. So we can only combine the variables that are the same. So x cubed and x squared, we can add those together to get x to the power of 5. And then y squared and y to the power of -4, we can add those together to get y to the power of -2. Remember, you can't have a negative and exponent. So the x is fine because it's got a power of 5, but the y squared is going to get sent to the bottom. That's because the negative exponent is going to flip the y. So right now the y would be over 1, so when I flip it, the y would switch to being in the denominator. So your final answer would be y to the power of 5 over y squared. Let's try the next one. We're going to start by dealing with our 10 and our 2. So 10 divided by 2 is 5, or I could reduce it to 5 over 1 if I divide them both by 2. Then let's look to our a's. A to the power of 5, subtract a squared. That's because they're dividing, so we're going to subtract the exponents. Will give me a to the power of 3. The next one, we have b cubed, and we're going to subtract a -2. So when I subtract the -2, it's going to become adding. So really this is going to be b to the power of 5. I don't really need that 1 in the denominator because dividing anything by 1 is just itself. So our answer should be 5a cubed and b to the power of 5. So I'd like you to take some time here and only complete the first column of numbers 3 through 10. There's also a quiz to complete at this point with some of the basic exponent laws. So make sure you get these ones down first before they get any more difficult. Good luck, and let me know if you have questions.